welcome to the Chicago Math Lab Fun Probability Problem Solving Sessions. So today we're going to take a look if we have joined the PDF for the two variables. If one want to find the probability for the certain type of the combination of the variable, like for example, this one we want to looking for the W less than Z, then how do we do this type of the probability problems here? Okay, so let's go ahead, go to our whiteboard, and we can start to solving these problems here. Okay, so let's try to write these problems here. So we said we have a joint distribution of W and Z. And so the W and the Z here is the functions here is 2 the W plus Z. And for the W greater than 0, Z greater than 0, and 3W plus Z greater than 3, less than 3 here, and equal to 0 otherwise. Okay, so then today we're going to do is try to find the probability W less than Z here. Okay, when we try to do this type of the problem here, the first things I will always recommend the student and try to do a graph. And most importantly, for those type of the problem, the most important is the where is the domain of those function was defined here. Okay, so now let's go ahead and start it. Okay, so let's take a look at this coordinate systems, W and Z here, right? Okay, so I would say this is my W and this is my Z here. And so this is like I said, 1, 2, 3, 1, 2, 3. Okay, so if you take a look at the first two conditions, W greater than 0, W greater than 0, and Z greater than 0, that means will be the first quadrants, right? So then the next conditions here, this is 3W plus Z less than 3. So in order to do this, the first we will try to set it is equal. So we'll say 3W plus Z is equal to 3 here. Okay, so 3W plus Z equals to 3. So when Z equal to 0, and what is my W here? So my W, so 3W plus, so W equal to 0. W equal to 0, Z equal to 3, right? So this one's here. Then when the Z equal to 0, W equal to 1. So this is the line we're going to have. So this is the first, okay, so hope all right, so this looks pretty good. So this is my lines here, right? So this line is 3W plus Z equal to 3. And then we use the algebra inequality. So which region is less than 3? So it will be below these lines, right? So it will be these triangles here. I don't want to, so let's see here. So it will be, let me use light colors here. So that means it will be this light blue areas, right? So this is my domain for these functions here. Okay, so now for doing this problem, this type of problem, then the next thing here is try to see what your probability you try to find. So like in here, I'm looking for the probability is what? W less than Z. So let's do the same things. Let's, instead of W less than Z, let's do the W equal Z here, right? Or you can say W minus Z equal to 0. Then let's try to graph this ones here. So when X equal to 0, when the W equal to 0, Z equal to 0, so will be this point. Then when W equal to 1, Z equal to 1 will be this point. So this condition will just be what? Will just be go over these lines, right? So this lines here is W equal to Z, but we want to find its W less than Z. So W less than Z, so which area is W less than Z? It will be these areas, right? So it will be the above area. So then, because this area is the common area for your domain and the probability I'm trying to find. So now I know this is the area. This I try to use the yellow, right? So this yellow area, maybe I can kind of, okay, so maybe, oops. All right, so I get rid of my line. That's not good. Okay, so here. All right, so now I know my common area is what? My common area is this yellow area. So this area is the one I want to find the probability. So then the remaining things here will just be, I'm going to try to integrate, use the calculus 2 double integrations here. Okay, so here, so you will integrate your PDF 2. So I take the 1/2 out. Then this is W plus Z, okay? And you can do DZ or D, the DW first. So in here, you need to choose smartly, right? So here I would do DZ first, okay? DZ, DW. Okay, so when you try to do the DZ here, right? So that means you integrate in the these directions here. Okay, so I typically tell my student you draw the line from the D is the vertical, right? So it's like here to here, and like for examples here, from here to here, right? Then from here to here, right? So this is the directions you're going to integrate. So where it start at this blue line. Now where it end in these black lines, right? From the z direction. So now I can write it out my boundary. So where is my boundary? DZ start with this blue line. So where start is z equal to w, right? So it start w. Then it's end at this black line. So what is the z going to be equal to? Z is equal to the 3 minus 3w's here, right? So it's 3 minus 3w. And so that's why my upper bound here is 3 minus 3w. If you already, so if you know this bound, then you almost, the hardest one is to try to find the bound, right? And the remaining just a simple kind of integration. Okay, now I want to see is, okay, after you integrate the z's, right? So I'm going to see where is my dw's here, right? So for all these things here, take a look. dw's here is going to start here and where the range for the dw is like so here let me try to do a dot line here, right? So this is a dot line here. So the range of the dw is start here to here, correct? So in order, so I know the W is start from 0, but where is this distance, right? So this distance is what? Is the intersection. So I need to solve this. So I say solve that 3W plus Z equal to 3, and the W minus Z equal to 0. So then you try to solve these two equations. So if I add it, I'll have 4W equal to 3. So what is my W here? W is equal to the 3 over 4. So I know this point here, right? So this is W is equal to the 3 over 4, and W equal to Z, so Z equal to the 3 over 4. So this is my point. So that's why when I do the integration for the 3W, this will be 0 to 3 over 4. Then your problem become a very simple problems here. So basically you just use the integration. So this is the 1/2. Then here this is 0, 3/4. And then you just do the integrations, right? So you integrate to z. So w is a constant. So what do you have here? You have wz plus the z square over 2, then you substitute the upper bound and the lower bound, right? And then you do the dw. So use a little bit of your algebra, substitute, expand, and you will get in here, it will be the 9 over 2, okay, minus 6w, and the dw's here. Okay, so now you do the integrations one more time. So this is 1 over 2, and so okay, so you will be okay, so here you will do, here is 9 over 2, the w minus what? Minus 3 over w what? Squares, right? And then you have 3/4 over 0, then you substitute, and your final answer is 27 over 32. So it's pretty easy. Like I said, the key things here is you need to know how to graph the domains, right? Then under the domain, you need to graph your function to see what is your function. Try to find here. Then just use the typical integrations, and that's it. All right, so this is a pretty simple problem. We're going to use the same joint PDF to do couple other problem, and will be a little bit more complicated. Like we want to show are they independent, or how do you find the covariance, those things. All right. So if you like the way I solve it, please, you can subscribe to the channel. And also, if you have any better way, unique way to solve this problem, and leave me a message. I would love to see it. Okay, sounds good. Talk to you later. Okay, bye-bye.